Alpha Lyrae, or as it's more commonly known, Vega, is the brightest star in the northern constellation of Lyra. This star is relatively close at only 25 light-years from the Sun, and is the most luminous star in the Sun's immediate neighbourhood. Fifth brightest star in the night sky, and the second brightest star in the northern celestial hemisphere. It's about time we revisited Alpha Lyrae. Hi everyone, Vega here, and in today's video we continue our Brightest Stars series with a trip to one of everybody's favourite stars, Vega. So let's get to it. We've looked at Vega before on this channel, in both Vega Standard Bearer, which was made some 4 years ago now, and indeed Vega Star. In this video, Vega Future, the third edition of the series, will principally be extending our knowledge, so do check out those videos first if you want more basic information on the star. At some point next year, I'll combine all three into a feature-length video, but for now let's get back to Vega. The apparent magnitude of Alpha Lyrae varies between a positive and negative. At its brightest, it can reach minus 0.02 and dimmest plus 0.026 magnitudes, and as such for many years, people classified it as exactly zero on the apparent magnitude scale. For this reason, Vega functioned as the baseline for calibrating the photometric apparent magnitude scale, and was indeed one of the stars used to define the 0 point for the system. Vega has some things in common with our Sun. Although it's only about a tenth the age, its expected lifetime is also 1/10 of that of our Sun, so both stars are at present approaching the midpoint of their main sequence lifetimes. If we look at stars in our local area, we know that from our solar system, Sirius shines brightest. But the truth is, until we reach Capella at 43 light-years away, it's actually Vega and not Sirius that is the actually most powerful star in our vicinity. It's just that Vega's slightly further away than Sirius, meaning it doesn't shine quite as bright here on Earth. Vega is the last of what you might call the elite stars, those that dip below zero in apparent magnitude. You can see here the list, and it includes Sirius, Alpha Centauri, Arcturus, and Canopus. And truth be told, you could even make it a more exclusive if you drop Ptolemy or Alpha Centauri b, as itself is not below zero in apparent magnitude, and it's only when you combine it with Rigel Taurus or Alpha Centauri a that the combination of the two stars dips below zero. In fact, Vega is actually moving towards us with a radial velocity of minus 13.9 km a second. And indeed, this means that in around 210,000 years, Vega will finally usurp Sirius and become the brightest star in our skies other than the Sun, reaching a maximum apparent magnitude of minus 0.81 some 270,000 years from now, before eventually then giving way to Canopus and disappearing into the void of the Milky Way. Vega, however, is to a degree the opposite direction of Sirius from our Sun, and is even further away from the dog star than we are, so it's not surprising that the brightest star in the star of Sirius's skies is not Vega, but Canopus. Indeed, it's only when we reach the star of Altair that Vega, instead of Sirius, becomes the brightest star in the night sky of that particular system. From Altair, Vega dips substantially into the negative apparent magnitude at minus 1.16, whereas Sirius from Altair has dimmed substantially and shines at a bright, but by no means outstanding plus 0.92. What all this means is that basically, and based on my own calculations, there is a trend in most of the close stars in the northern polar direction towards having Vega as their brightest star in the night sky, rather than Sirius or indeed Canopus. Although again, once we pass Vega and begin approaching Capella, everything changes again, as Capella is intrinsically brighter than both Sirius and Vega. If you look at the stars in terms of absolute magnitude rather than apparent magnitude, Vega is plus 0.58 compared to Sirius's plus 1.43, and Capella's double stars are substantially brighter than both, with a combined absolute magnitude of minus 0.52. Absolute magnitude, for those of you that aren't aware, is the measure of a star as if it was seen from 10 parsecs, or 32 light-years from Earth. Continuing on, compared to the Sun, Vega has a low abundance of elements heavier than helium, and the star's photosphere is only about 32% of the abundance of heavy elements as our Sun. While that may not sound great for possible planets in the system, based on observations of more infrared radiation than expected, Vega does appear to have a circumstellar disk of dust, and the dust is likely to be the result of collisions between objects in an orbiting debris disk, which in many ways is analogous to the Kuiper belt in our own solar system. And now though, an update on that, because recent observations from the James Webb Space Telescope have shown us that the disk is actually exceptionally smooth. This means that actually there is little evidence of shaping by massive planets, although there does remain some evidence that there might be one or more Neptune-mass planets closer into the star. The dust seems now more likely created by a debris disk around Vega, rather than a protoplanetary disk, which was earlier thought. So it is possible that the star does not, and presumably will never now have, a family of planets, which is quite sad really when you think about it. Of course, A-type stars like Vega, Sirius, Altair or Fomalhaut are thought to be the last vestiges where life like ourselves could theoretically exist. Once stars get hotter than the A-class, their lifespans becomes just too short for realistic chances of life to form in an habitable planet. It seems likely then that for now we can unfortunately probably rule out life in the Vegan system. In the sky, Vega lies at a vertex of a widely spaced asterism called the Summer Triangle, which consists of Vega plus a fellow A-type star of Altair in Aquila and the mighty Deneb star in Cygnus. Deneb though is a much more distant star than Altair or Vega. The formation is approximately the shape of a right-angled triangle, with Vega located at its right angle. And this summer triangle is very recognisable in northern skies, as there are very few other bright stars in the vicinity. Vega is also a star that is certainly not afraid of leading the way. Not content with being the standard bearer in terms of apparent magnitude, Vega is also one of 6 A0 main sequence stars that were used to set the initial mean values for the BV colour index, which is a simple numerical expression that determines the colour of an object. Indeed, Vega has a relatively flat electromagnetic spectrum in the visual region, and this means that most of the light coming from the star is what we see with our human eye. What we see is pretty much what we get with Vega. Indeed, this white main sequence star is currently fusing hydrogen to helium in its core, and given that more massive stars use their fusion fuel more quickly than smaller ones, Vega's main sequence lifetime is thought to be roughly 1 billion years, or again about a tenth of the Sun's. And its current age of 455 million years means again Vega is about halfway through its main sequence life. Once the star does leave the main sequence, it will swell into an M-class red giant and shed much of its mass before finally becoming a white dwarf and fading away over trillions of years. At present, Vega has more than twice the mass of the Sun, so its future seems to be likely to have a destiny similar to the Southern Cross star of Gacrux or Gamma Crucis, a red giant star that's substantially larger than both Aldebaran and Arcturus, as we see here in this diagram. When this happens, Vega would become around 20 times brighter than it is now, or some 800 to 1000 times brighter than the Sun. When this happens, however, the star will have begun to disappear into the void of the Milky Way, and won't remain quite as remarkable a star as it is today, at least from our skies. Vega, or Alpha Lyrae, is the most powerful star system within 40 light years of Earth. The star has a circumstellar disk, but it's thought not to host planets or protoplanets. Vega is a standard bearer both in terms of the apparent magnitude and the BV colour index scales. One of an elite group of 5 stars, Vega occasionally dips below 0 in apparent magnitude, and indeed it's halfway through its life, and in 500 million years or so will expand into a large red giant star and reach as much as 1000 solar luminosities. For now, life in the Vegan system is ruled out, but our eyes do remain fixed to this local, yet incredible, pure white star. Thanks for watching and consider subscribing if you haven't already. If you would like to support the channel further, you can consider joining the channel, or alternatively buy me a coffee, and this is linked in the description. Many thanks to those of you who have done so already. Take really good care of yourselves, look after your friends and family well, and I'll see you on the next one.